Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS concepts. In two lectures before this lecture, we have taken a very big numerical in which there are numerous parts are there, out of which we have done two parts. Part 1 is completed, where we could find out the bending stress, allowable bending stress. In part 2, we could find out the point load on the cantilever beam, value of P, external loading. Cantilever beam is of 1 meter length, and external P we have found out as P is equal to 1.1 newtons, that is equal to 0.11 kg in mass. Because mg is equal to Newton, Newton divided by g is equal to kg, that is mass. We have discussed that in the previous lecture, two lectures before this, that mass is to be taken. This is the external, this is the self weight, or we can say external load and self weight, or external mass and self mass. It is the same. That weight means multiplied by g, load means multiplied by g, and either we can take it both in same units, whether it should be in kg or Newton accordingly. If it is taken in kg, like P is in kg and M is in kg, then this formula will be workable. If it is in Newton, then we have to multiply this formula with g. Now, we will further try to solve this problem. What is the value of P? P is equal to 0.11 kg. What is M? M is equal to rho into volume. What is the rho? Rho of steel, we can take it as 7860 kg per cubic meter. What is the volume? It is a diameter of 0.05 meters, 50 mm diameter circular pipe with a length of 1 meter. Pi by 4 d square into L. This is the volume. Let us find out the volume. Volume is pi by 4 into 0.05 whole square into L is 1. That is equal to 15. Let us keep it this way only. Now, what is the mass? Mass is equal to rho into volume. That is, rho is 7860 into volume is pi by 4 into 0.05 whole square into 1. Let us do this calculation. Pi divided by 4 into 7860 into 0.05, that is coming to 15.43 kg. This is the self weight of the beam. Now, once we know the self weight and once we know the external load in kgs, both are in kg, in same unit, then omega square is equal to 3 EI by P plus 33 by 140 m L cube. That means, what is P? P is in kg, m is in kg. Then you will get omega square. Let us try to find out the dimensions of the right hand side. 3ei by P plus 33 by 140 m into L cube is equal to 3 into Newton per meter square E. I is meter to the power of 4 divided by kg plus 33 by 140 into kg into cubic meter. That means right hand side is equal to, let us forget about the numerals, values do not have any dimensions. Then Newton into, numerator will be Newton into meter square, because Newton per meter square into meter to the power of 4 is Newton meter square, whole divided by kg into m cube. That is equal to Newton by meter kg. What is Newton? Kg into meter per second square. MA is equal to force as per Newton's law. Here kg into meter. That implies right hand side is equal to, meter gets cancelled, kg get cancelled, it will be 1 by second square. That is equal to radians by second whole square. That is equal to omega square. That means if P and M are in kg, the frequency will be omega square is given by 3i by P plus 33 by 140 m L cube. This omega can be converted to frequency. Frequency is equal to omega by 2 pi. That is in hertz. This omega is in radians per second. Now, with this background, let us solve the question given. Now, what are the values given? Let us take E for steel as 200 GPa, which is nothing but 200 into 10 to the power of 9 pascals, is nothing but 200 into 10 to the power of 9. G is giga means 9, mega means 10 to the power of 6, giga means 10 to the power of 9, kilo means 10 to the power of 3, into pascal means Newton per square meter. I is equal to how much? For a circular beam, I is pi by 64 into d to the power of 4. That is pi by 64 into 0.05 to the power of 4. That is equal to 3.068 into 10 to the power of minus 7 m to the power of 4, m4. Let us see. Pi by 64 into 0.05 to the power of 4. .068 into 10 to the power of minus 7. That is I value. Once we got the I value, E value, P value, M value, and what is L? Here we have written L is equal to 1 meter. Once we got all the values, it is just nothing but substituting these values and getting the value of omega square. That is, omega square is equal to 3ei by p plus 33 by 140 m L cube. That is equal to 3 into 200 into 10 to the power of 9 into what is I value? 3.068 into 10 to the power of minus 7 whole divided by P is 0.11 plus 33 by 15.43 is m. 33 by 140 into 15.43 into L cube is 1 cube, which gives omega square is equal to 49414 radian square per second square, which is nothing but 223 omega is equal to 223 radians per second. This is the answer in radians per second. Natural frequency. Natural frequency in hertz is equal to omega by 2 pi. That is equal to 223 divided by 2 into pi. That is equal to 35 hertz. This is the natural frequency of a cantilever beam having a length 1 meter and having 15.43 as self weight kg and applied by 0.11 kg external load. It has a frequency, natural frequency of 35 hertz. For example, self weight is neglected. Let us say if self weight is neglected, self weight is equal to neglected, then what happens? M is equal to treated as 0. That implies omega square is equal to 3i by PL cube. That implies omega is equal to 1297 radians per second, which says natural frequency, lowest natural frequency is equal to 206 hertz. That means why we have considered the self weight here. The reason you please try to understand. This type of questions may come in your examination, especially in SSC JE. If self weight dominates over external weight, in that case it is preferable to take self weight into consideration account. First point. What happens if self weight is taken into consideration? The frequency reduces. The natural frequency reduces if self weight is taken or accounted for. The natural frequency without self weight is greater than Fn without self weight is greater than Fn with self weight. Whether you call it, if you take in hertz it is Fn, if you take in radians per second it is omega. Fn or omega without self weight is greater than omega with self weight. That means self weight reduces the natural frequency. That is the most important thing. Natural frequency is reduced. What is the effect of self weight? Self weight reduces natural frequency of beam. That means stiffness of the beam increases. Beam increases. That means if frequency is less, means more stiffness is there. It is not vibrating freely. If frequency is more, means it is vibrating freely. Frequency will be more when self weight is less. That means thinner rods or lighter beams vibrate more than the heavier beams. Please make a note of it. With this, I want to conclude the topic of vibrations in the beams. Please refer to my earlier lecture. Almost 3 lectures I have completed on this topic. Please refer to them, review them, comment on them. I will reply. And please subscribe to my channel CIVIL-MECH-MATHS Concepts. Best of luck to you in your examination. Thank you. Thank you for listening to me.